This ship is 1,000 years old in design. It crossed the Atlantic Ocean in open water, with no engine, no GPS, and no metal hull. Modern recreational boats, built with satellites, weather forecasts, and fiberglass, still capsize in conditions Viking ships sailed through on a normal day. Viking shipbuilders weren't lucky. They understood something about wood, water, and movement that most modern boat builders never had to learn. And once you see how their ships actually worked, modern boats start looking strangely over-engineered. Start with the wood. Viking ships were built almost entirely from oak, split along the grain rather than sawn across it. That distinction matters more than it sounds like it should. Sawing a log cuts straight through the wood fibers, weakening them at random points. Splitting wood along its natural grain keeps those fibers fully intact from one end of the plank to the other. The result was wood that could flex repeatedly under pressure without cracking, which turned out to be exactly what a ship needed. Because here's the thing modern boats don't do. Viking ships were built to bend. The hull wasn't rigid. It was designed to flex with the waves instead of fighting them. Picture the difference between a stiff plank and a green branch. Snap the plank hard enough and it breaks instantly. Bend the branch and it simply curves, absorbing the force instead of resisting it. Viking ships worked the same way. The hull could twist several inches in rough seas without taking on damage, because the entire structure was engineered to move. This is where it gets genuinely strange. And it's the part most people don't expect. Modern fiberglass and aluminum boats are built rigid on purpose, because rigidity is cheaper to manufacture and easier to standardize. But rigid hulls fight the ocean instead of working with it. In serious waves, that stiffness transfers stress directly into the hull at fixed points. And fixed points are exactly where boats crack, where seams fail, where small leaks start. A Viking longship absorbed that same wave energy across its entire flexible structure instead of concentrating it anywhere. The ship that seems primitive on paper was actually solving a problem modern boats still struggle with. The shape mattered just as much as the material. Viking ships had a shallow draft, meaning very little of the hull sat below the waterline. That let them sail in water barely a few feet deep, beach directly on open shoreline with no harbor required, and still handle deep ocean swells without flipping. Most modern boats can do one of those things well. Viking ships did all three because the hull shape, long, narrow, symmetrical at both ends, was tuned for stability in completely unpredictable conditions, not optimized for a single use case like most boats are today. And then there's the keel. A Viking ship's keel ran the entire length of the hull as one continuous piece, usually cut from a single massive oak tree. That single-piece keel gave the whole ship a structural spine, distributing stress evenly from bow to stern. Modern boats build keels in sections, bolted or welded together, which means there are now multiple joints where stress can concentrate and eventually fail. The Vikings weren't avoiding that problem because they thought it through, theoretically. They simply didn't have the manufacturing process that creates the problem in the first place. And in this one specific way, that limitation made their ships stronger, not weaker. So here's the part that should genuinely bother you. With all of that, flexible hulls, shallow draft, a single-piece keel, Viking sailors crossed the North Atlantic to Iceland, Greenland, and eventually North America, roughly 500 years before Columbus. No compass for most of that history, no charts. They navigated using the position of the sun, the behavior of ocean swells, the flight patterns of birds, and a possible mineral called sunstone that may have let them locate the sun's position even through heavy cloud cover. Some of this is still debated by historians, but the outcome isn't. Ships built from split oak and instinct made it across one of the most violent oceans on Earth, repeatedly, without losing the technology that made it possible. Compare that to today. A huge share of recreational boating accidents happen in conditions that are mild by historical standards. Choppy water, moderate wind, nothing close to what Norse sailors treated as a normal Tuesday. Rigid hulls crack under stress that a flexible Viking hull would have simply absorbed. GPS fails or loses signal, and many modern boaters have never had to navigate without it because they've never needed to learn. None of this means Viking ships were better in every way. They were dangerously exposed to weather, offered no real shelter, and depended entirely on human strength for propulsion when the wind died. Long voyages were brutal, and the survival rate for serious North Atlantic crossings was far from guaranteed. This isn't a story about ancient people having access to secret superior technology. It's a story about Viking shipbuilders deeply understanding the one material they had, while a lot of modern boat design optimizes for cost and mass production instead of how the ocean actually behaves. And that gap is exactly what some boat designers are starting to revisit. Naval architects studying historical Norse vessels have looked seriously at flexible hull design for small craft, especially for boats meant to handle rough coastal water rather than calm lakes. The idea that a hull should move with the water instead of resisting it sounds almost backwards by modern engineering standards, until you remember it kept ships intact across the Atlantic for centuries before steel ever touched a hull. The real story isn't that Vikings had better technology than we do now. It's that they had no choice but to understand their one material completely while we've built an entire industry around not needing to. A shipbuilder 1,000 years ago could read a tree and predict exactly how it would behave on open water for the next 20 years. Most of us can't tell you what's actually inside the hull of the boat, sitting in our own driveway. That's the real difference. Not technology, understanding.